I'm Cziryll Rose Palileo from BS Chemical Engineering in PLM, third year. Together with my group mates, Kenstin H. Luistro and Roel Ian M, Cruz, we will discuss about the analysis of structures. First, I will discuss about the method of joints. So, we have the problem. Find the force acting in all members of the truss. Given the 80 kilonewton in joint C, the 50 kilonewton in joint F, they are the external forces including the hinge and rollers in joint A and joint D. So, first, we have to determine the FBD for this equation or for this problem. This is the FBD. We have um, the RD for the rollers in joint D, and the AH and AV or the vertical force and horizontal force in joint A, and of course the other forces in the I mean the other external and internal forces in the problem. So what are the required in this problem? We are searching for the force in AB, force AE, force BC, force BE, force CD, force CE, force CF, force DF, and force FE. In order to solve one of this, we must separate the different joints from other joints, just like this. First, we have the FBD for joint A. Using this FBD, we will answer or we will get the force in AH and some other force. Let's solve it. But before solving for it, let's go back to our main FBD. Let's solve for the internal forces. So, this is the equation for getting the AV using the summation of force in the summation of moment in joint D. We have 3AV plus 50 times 1, which is here 50 times the different difference of the distance from joint D to the joint F, and 80 times 0.75, which is the vertical distance of joint C to joint D. And we have 3.33 kilonewton. And finding the summation of forces or external forces in this diagram, we have summation of horizontal forces is equal to 0. And the only horizontal forces in this equation, we have the 80 kilonewton and the AH, which is, so AH, or the horizontal force in A, is equal to 80 kilonewton. So that. Moving on, we will also have the RD. We will get the value of RD using the moment, summation of moment in joint A. So we have three RD is equal to 50 times 2, 50 and 2, because we have the summation of the distance of joint F to joint A, and plus 80 kilonewton multiplied by 0.75, the vertical distance of the two forces. So we have RD is equal to 53.33 kilonewton. At joint A, we have the summation of vertical forces is equal to 0. So 3/5 of force AB is equal to 5.56 kilonewton tension. So we have force AB is equal to force AB is equal to 3.33. So the final answer, we have 5.56 kilonewton for force AB. For the horizontal force, summation of FH is equal to 0. FAE plus 4/5 FAB is equal to 80. FAE plus 4/5. We have AB 5.56 is equal to 80. We have FAE is equal to 75.56 kilonewton. So, moving on, we have the FBD for joint B. So, using the horizontal force, summation of horizontal force is equal to 0. FBC is equal to 4/5 FAB. FBC is equal to 4/5 5.56. And so we have 4.45 kilonewton. Summation of vertical forces is equal to 0. We have FBE is equal to 3/5 FAB, which is also equal to 3/5 AB is equal to 5.56. And so we have FBE is equal to 3.34 kilonewton. And this is in compression, not like all the other which are in tension. So, we're done for the FBD of joint B. Let's move to the FBD for joint E. Summation of forces in vertical forces is equal to 0. We would divide it at joint E. 3/5 FCE is equal to FAE, which is also equal to FAE is equal to 3.34. So FCE is also equal to 5.57 kilonewton tension. The summation of force in the horizontal is also equal to 0, which is also equal to force in FE plus 4/5 force in CE is equal to force in AE. Substituting the different amount or different values, known values, we have force in FE is equal plus 4/5 5.57 is equal to 75.56. So force in FE is equal to 71.11 kilonewton tension. Let's go to the free body diagram in joint E. I mean joint F. we have the summation of vertical forces. It is also equal to 0, and FCF is equal to 50 kilonewton tension. Summation of force of horizontal forces is equal to 0. FCF is equal to 50, FDF is equal to FFE. So we have FDF is equal to 71.11 kilonewton tension. So, moving on to the free body diagram of joint F, we have the free body diagram of joint C. The summation of horizontal forces is equal to 0, and for fifth FCD plus 4/5 FCE plus FBC is equal to 80. And for the FCD, for fifth FCD, we have for fifth FCE is equal to 5.57 plus FBC, which is equal to 4.45. They are equal to 80. So, simplifying the values, we have FCD is equal to 88.87 kilonewton compression. And compress. So, for the vertical, it is equal to 0. We have 3/5 FCD is equal to 3/5 FCE plus FCF. Substituting the values, we have 3/5 88.87 is equal to 3/5 5.57 plus 50. We have 53.3 is equal to 53.3. So check, we have the values that we get are all equal. This is only for the checking. And lastly, we have the FBD for joint D. The summation of forces, of horizontal forces in joint D is equal to 0. We have 4/5 FCD is equal to FDF. Since we got all the values already, we just have to check for the values if they are equal. So we have
4/5 F FCD is equal to 88.87 is equal to 71.11. So 71.1 is equal to 71.11. So check, we got the values correctly. Summation of vertical forces, we have RD is equal to 3/5 FCD. 53.33 is equal to 3/5 of 88.87. We have 53.33. It's also equal to 53.33. So check. To summarize all the values that we got, we have this. So putting all solved values, we have FAB is equal to 5.56 kilonewton tension. FAE 75.56 kilonewton tension. FBC is equal to 4.45 kilonewton tension. FBE is equal to 3.34 kilonewton tension. So FCD, we have 88.87 kilonewton compression. And the FBE, it is compression. FCE 5.57 kilonewton tension. FCF 50 kilonewton tension. FDF 71.11 kilonewton tension. And lastly, FE, which is also equal to 71.11 kilonewton tension. So this is the summary for the ask in the problem. Get all the, or find all the forces in the problem.
So, hi everyone. I will be discussing method of sections. So, the process of which you cut the truss into two sections by passing a cutting plane through the members whose internal forces we wish to determine. So, the cut members will be replaced by forces equivalent to the internal load transmitted to the members, and they are non-concurrent force system. So you don't want to cut the truss. You don't want to cut more than 3 members of the truss. So let's get started. So this is the figure in which the internal forces we want to know is DE, BE, and BC. So in order for us to determine what the value of BE is, we have to use the left side of the section. So first we are going to find the summation of the forces on Y. because we have a force here on A, which is in the y-axis, and it is 80 kilonewtons, and the force here in B, 60 kilonewtons, which is also in the y-axis. So we have to determine the summation of the forces in y, which is equal to 0, so that we can determine what the value of BE is. So there you go. Summation of forces along the y-axis is equal to 0. So 0 is equal to negative 80 kilonewtons. It is negative kasi it is going downward. So negative 80 kilonewtons, negative 60 kilonewtons, which is here in B, and the BE. The BE has an angle, so it means it has an x and y component. So we only need the y component, so we will determine what sine theta is. Since there is no angle, we can use this right triangle to determine what is the value of sine theta. So here, since this is DE is equal to 4, and you got it in half because you only need BE, so it is 2 meters, and since it is given here that the vertical member is 5 meters, so we have 5 meters here. So we have to determine what is the value of the hypotenuse. So using the Pythagorean theorem, we can solve for the hypotenuse, which is square root of 29. So right now, we all know that sine theta is equal to opposite over hypotenuse. But which angle do we need? Which angle will we use? So here, B, the angle here is equal to the angle here. So we will use the angle here. And the opposite is 5. So 5 over hypotenuse, which is square root of 29. So that is the value of sine theta. So here, back to the equation. BE multiplied by sine theta, which is 5 over square root of 29. So solving the problem, BE is equal to 158.78 kilonewton. Since it is going away from B, it is tension. So the next is we will use moment in E. So moment here in E. So BE is not included because it passed through E. DE is also not included because it also passed on E. So the only forces included on the left section is 80 kilonewtons, 60 kilonewtons, and BC. I mean here. So here. And so we can determine what the value of BC is. So here the equation is summation of moment in E is equal to 0. So 0 is equal to BC. So this is BC, and multiplied by the perpendicular distance to E, which is the vertical distance, and the value is 5. So the next is 60 kilonewtons, which is going downwards, and it rotates rotates the truss counterclockwise, so it's negative. So negative 60 kilonewtons multiplied by the perpendicular distance to E, which is horizontal. So this is 2 here, right here, 2 meters, so 60 multiplied by 2. And finally, the force on A, it also rotates the truss counterclockwise, so it's also negative. So its perpendicular distance is 4 plus 2, it's 6. So 0 is equal to PC multiplied by the perpendicular distance of 5 minus 60 kilonewtons times 2 meters minus 80 kilonewtons times 6 meters. So BC will be equal to 120 kilonewton. And since it's positive, meaning it rotates the truss clockwise, so here's the force B. It's going towards B, so it's clockwise and it's positive, so it's compression. And now we have obtained BE and BC. The only internal force we need to determine is DE. So in order to determine DE, we will use the summation of moment on B. So summation of moment on B, we cannot use DE, BC, and the 60 kilonewtons. So the forces that we can use is force on A and force on DE. So 80 kilonewtons is negative because it rotates counterclockwise. So we need this DE to be positive, so it's tension. There. So we go to the formula. Summation of moment at B is equal to 0. 0 is equal to negative 80. Negative 80 because, as I said a while ago, it rotates counterclockwise, so negative 80 multiplied by its perpendicular distance to the force B, so it's 4 plus DE, which is a tension, because it needs to be positive, so positive DE, and multiplied by the perpendicular distance of 5, so the value of DE will be 64 kilonewtons and its tension. So that wraps up, because we have determined BE, BC, and DE. So there. A little tip: you can only cut the truss with a vertical or diagonal plane. And you cannot cut 3 or more than 3 members. So like here, I cut it diagonally. So the internal forces we need to know, as we have solved it, is DE, BE, and BC. So there, I cut it there. So thank you.
I'm Kenstin H from Pagpantasan ng Luzon ng Maynila, and I'm here to present to you the method of members. So, for the method of members, we are given the structure shown is pinned together at points A, B, and C, and held in equilibrium by the cable CD. A load of 12,000 pounds is acting at the midpoint of members A and B, and a load of 8,000 pounds is applied at point C. So we are asked to determine the reaction at A, the internal force in member B and C, and the tension on cable C and D. So, for the first step, we assume that Ty is equal to T cosine 53 degrees, Tx is equal to T sine 53 degrees, and to find the length C, A, and B, we derive the formula A is equal to 16 cosine 30 degrees, or it is equal to 13.86 meter. B is equal to 16 sine 30 degrees, equal to 8 meter, and C equal to A times tan 37 degrees, or equal to 10.44 meter. And to find the tension on cable C and D, we moment in point A, and the summation of the moment in point A is equal to 0. So T sine 53 degrees times 8 plus 10.44 is equal to 8,000 times 13.86 plus 12,000 times 4, and T is equal to 10,788.47 pounds. To find the reaction at point A, first, summation of MD, or the moment, is equal to 0. Then AX times 8 plus 10.44 is equal to 8,000 times 13.86 plus 12,000 times 4, and AX is equal to 8,616.05 pounds. And to compute the AY, we use the summation of Fy is equal to 0. Then AY times T cosine 53 degrees is equal to 8,000 plus 12,000. And substituting the T, or the tension, AY plus 10,788.47 cosine 53 degrees is equal to 8,000 plus 12,000, and by computing, we calculate AY is equal to 13,507.34 pounds. And finally, to compute the reaction at point A, the square root of AY squared plus AX squared, or the square root of 8,616.05 squared plus 13,507.34 squared. So the reaction at point A is equal to 16,021.38 pounds. And to find the force B and C on member CD, so first we must found the beta. And to find that, tangent beta is equal to 813.86 minus 8, then the beta is equal to 53.78 degrees. And we use again the moment in A, and the summation of moment in A is equal to 0. Then force BC sine beta times 8 is equal to 12,000 times 4, and substituting the beta, force BC sine 53.78 degrees times 8 is equal to 12,000 times 4. Then lastly, the force BC is equal to 7,437.21 pounds. So overall, the tension on cable C and D is equal to 10,788.47 pounds. And the reaction at point A is equal to 16,021.38 pounds. And lastly, the force in member B and C is equal to 7,437.21 pounds.